Then we move on to basic data pre-processing. So train process is equal to train df.copy, train test pre-process equal to test df.copy. Basically, it just creates copies for the pre-processing. Then we print out like the missing values in the train df. So train process is null.sum. And then we do basically print checks for any of like the missing values and duplicates. Then we move on to train processed is equal to train process that drop duplicates, which is done the same thing for the test process. Basically, this like removes any duplicates, if any, and then these are all the missing values in the training df, which is 12. Then we move on to label encoding for categorical features. So if we import label encoder from sklearn pre-processing, then we say categorical features is equal to gender, subscription type, and contact length. This helps us identify like the categorical features. Then label encoders is equal to brackets empty. Basically, this creates a dictionary to store the label encoders. Then we do for feature in label and categorical feature. Basically, this applies the label encoding to each of the categorical features. Then LE is equal to label encoder, LE feed trained trans preprocess brackets feature. Basically, what these two line of code does, it basically initializes and fits the label encoder. Then we move on to train processed feature plus encoded is equal to LE transformed train preprocessed the brackets features, which is done for the test preprocessed, but it's replaced by test preprocessed. Basically, what these line of code does is basically transforms both the training and the testing data. Then we move on to label encoder brackets features equal to LE. We basically store like the encoder for like the future use basically. Then we move on to print label encoder by feature for I category and numerant LE classes. Is equal to print brackets category is equal to I. Basically, what the line of code does is basically loops through each of the unique category and like the features and stores them in the LE classes, and then it prints like each of the original category values alongside with its like encoded numerical values. Then we move on to encoded columns is equal to gender all the way up to contact length encoded, which then is train preprocessed brackets encoded columns is equal to head. Basically, what these line of code does is basically this creates like a list of column names that includes both the original column names and their encoded version, and basically then it displays them with the first few rows of the training data showing only these selected columns. So as we can see, table encoded for gender, female becomes 0, male becomes 1, nan is 2, and then label encoding for subscription type, where basics 0, premiums 1, standards of 2, and nan is 3, label encoding for contact length, annual 0, monthlies 1, quarterlies 2, and nan is 3, and then these are the encoded versus like the original, and for these are done for the subscription type on the contact list. So yeah. Then we move on to feature engineering to create time-based features. So time-based features, basically train preprocessed tenure age is equal to train preprocessed tenure divided by train processed age. Basically, this gives us the train to age ratio for both the train processed and the test processed, and then we move on to contact 2 months is equal to monthly to 1, quarterly 3, and annual 12, which is then we move on to train preprocessed contract months is equal to train preprocessed contract length on map track 2 months. Basically, what these line of code does, it basically converts the contract lengths to the months for calculations for both like the train preprocessed and the test preprocessed. Then we move on to the train preprocessed monthly spend is equal to train preprocessed total spend divided by the train preprocessed times the train preprocessed tenure. Basically, this gives us like the monthly spend calculation for both the train process and test process. Then we move on to relative inactivity, which is equal to train preprocessed last interaction divided by train preprocessed tenure. Basically, this gives us the relative inactivity, basically like the last interaction relative to tenure for both the train preprocess and the test preprocess. Then we move on to supports per month is equal to supports call divided by tenure. Basically, this gives us supports per call for the train preprocess and the test preprocess. Then we move on to the usage per month, which is divided by tenure preprocessed usage frequency divided by trainer preprocessed tenure. Basically, this gives us like the usage frequency for both like the train for process and the test process. Then we move on to train preprocess replaced np infinity divided by np infinity negative infinity np invalid n plus true, which is basically what these line of code it basically handles like potential infinities, and then train preprocess.fill na basically it handles like NaN values for both the train preprocessed and the test preprocessed. Next, we move on to feature transformation by applying log transformation to skewed features. So numerical features is equal to age, tenure, and all the way up to usage per month. Basically a list to check like the skewness of like each of the numerical features. Then we do skewness is equal to train preprocessed brackets numerical features dot skews dot store values ascending is equal to false. Print feature skewness, print skewness. Basically, this calculates the skewness for each of the features. And then we do feature to transform is equal to skewness brackets absolute parentheses skewness greater than 0.5 dot index to list. Basically, this selects the features for like log transformation if like the absolute skewness is greater than 0.5, and then we print out the feature to transform. So here are all the feature skewness in the descending order. So the most is like monthly spend followed up by support calls per month, and then the lowest is like total spent. Here are all the features selected for log transformation, as these are like the top 6. So like monthly spend all the way up to like support calls. So yeah. Next we move on to for feature and feature to transform to then train processed brackets feature plus log is equal to np log np train processed brackets feature, which is similar to test preprocess. Well, basically what this block of code does is it loops through each of like the feature identified as needing like log transformation from like the feature to transform list, and it applies the transformation to both like the training and the testing data sets. Then we move on to if length is equal to features to transforms greater than 0, features is equal to feature to transform bracket 0, fig x is equal to plt dot subplots 1 2 fig size equal to 15 comma 5. Well, basically what this block of code does is it basically visualizes the before and after of the log transformation for like a highly skewed feature. Then we move on to SNS histoplot train processed brackets feature, comma KDE equals true, x is equal to x is bracket 0 with the title over here. Basically what this line of code does is basically creates like a histogram of like the original features using like Seaborn. Then this one titles it. Then we move on to SSN history plot with train preprocessed brackets feature plus log comma with all these parameters, and then sets the title over here. Basically what this line of code does is it basically creates like a histogram of like the log transformed features, and then afterwards we plot this. So here's the diagram for like before and after. So basically the transformation basically improved like the distribution of like the monthly spend. As we can see, before the skewness was like 10.38, and now it's down to like 0.89, which will significantly help our modern's performance later on.